Hello, welcome back to Chemistry. It is all that matters. And now that we know how to determine the empirical formula, we need to know how to convert empirical formula to molecular formula. So let's move forward, and first let's remind ourselves of what exactly molecular and empirical formulas are. So as we talked about in the last video, empirical is the lowest ratio value of the atoms of the element, where the molecular formula is the true formula, and we looked at acetylene C2H2, empirical is CH, benzene molecular is C6H6, empirical is CH because it is a 1-to-1 ratio. Carbon dioxide, the empirical and the molecular are the same because it's already in the lowest form, and ribose, which is C5H10O5, can be reduced to its empirical CH2O, reducing everything by a factor of half. So we end up with 5 to 10 to 5 equaling 1 to 2 to 1. So let's move on. So again, the empirical formula represents the simplest whole number ratio of atoms, and they must be whole numbers. You cannot have partial atoms. And then the molecular formula is the true ratio of the atoms in that compound. So we went through some of these examples, and we remind ourselves that for C4H8, we are looking at a value of reducing that value to CH2, which would be this value right here. For C8H14, we reduce it to this value here, C4H7. And for the molecular formula CH2O, we are looking for values for that empirical formula, and CH2O, C2H4O2, and C3H6O3 all are molecular formulas for that empirical formula. And again, when we look at the molecular formula of 4 atoms of nitrogen, if the empirical is S to N, a 1-to-1 ratio, our molecular formula would be S4N4. So let's move on. And what we're going to use, this is a formula box for converting empirical formulas to molecular formulas. So we need a box of 4. On the left we have empirical and molecular, and across the top we're dealing with the formula and the mass. So if our question is, compound is 71.65% chlorine, 24.27% carbon, and 4.07% hydrogen, what are the empirical and molecular formulas? The molar mass is known to be 99.0 grams per mole. So we already solved this in the previous video on empirical formula, and we came up with an empirical formula of CH2Cl. And what we're going to do is we're going to place that empirical formula in the box, and we're going to find the molar mass of that empirical formula. So C is 12.01, H2 becomes 2.02, and Cl becomes 35.45. So we add that up and get 49.48, and that is going to be the mass of that empirical formula. Now, what we next look at is what is the molecular mass? Now, the molecular mass was given to us in the problem. If we remember, we go back to this molecular mass, molar mass 99.0. So what we're going to do is we're going to put that 99.0 in the box. So now we have a situation where we can calculate our information. Now remember, what we can do is figure out that 99.0 divided by 49.48 is 2. So we're going to multiply each of the values of the empirical formula by 2 to get our molecular formula, which becomes C2H4Cl2. So here are 2 sample problems, and what we can do is we are given the molar mass, or molecular mass, of galactose, and we are told the percent compositions for each of those. And I want you to go ahead and calculate the empirical and molecular formulas for galactose, and then go ahead and do the same down here for phosphorus and oxygen, and we'll see how you did. So go ahead and turn off the video, work out these two problems, and then come back and see how you did. Okay, so for the first problem, what we end up with is an empirical of CH2O, and the mass of that empirical is 30. 30 goes into 180.18, which is the molecular mass given to us in the question, and that goes in 6 times. So when we multiply C 1 times 6, we get C6. H2, 2 times 6 is 12, H12, and oxygen 1 times 6 is 6. So we end up with C6, H12O6, which of course we know is the formula for glucose, fructose, galactose, and so on. So a sample of 21.82 grams of phosphorus and 28.18 grams of oxygen. Now in this case we weren't given percents, we were given the actual gram mass, so we're going to simply change grams to moles and find the empirical formula. And so when we do that, we get an empirical of P2O5, a mass of 142, and because our molecular mass in the question was 283.88, we know that 142 goes into 283.88 2 times. So we multiply P2 times 2 and get P4, O5 times 2 and we get O10. So this is the basic format you can use to convert empirical formula to molecular formula in chemistry. So keep working on chemistry because it's all that matters.